Welcome to a heparin infusion with protocol problem. First, we'll take a look at the actual problem itself. The physician has ordered intravenous heparin for your patient following the cardiology protocol. Use the order sheet, appropriate nomogram, and labels to answer the following questions. Let's take a look at all the pieces of information that we're given. First, the order sheet. On the order sheet, I notice that there are no known allergies. I notice the patient's weight, and I notice that there's been a significant amount of lab work ordered. I notice that if there's significant bleeding or neurological changes, I need to notify the physician. I need to notify the physician prior to the fourth adjustment, and I need to choose the appropriate part of the protocol. So I already know the appropriate part of the protocol because I was told to use the cardiology protocol. I want to make note of the patient's weight because I'll need that for a heparin protocol problem. Next, I'll take a look at the protocol itself. I know to focus on the cardiology part of the protocol. I see the initial bolus, I'll need that for the problem, and I see the maximum of 5,000. I see the initial infusion. Again, I'll need that for the problem. And again, I see the maximum. Based on the lab work, I'll adjust the heparin once I get to that part of the problem. Last, I'll look at the meds that are available. I have a vial, which would be used for the bolus dose. The strength of this is 5,000 units per milliliter. I have an IV bag which will be used for the heparin infusion. The strength of the IV bag is 25,000 units per 250 milliliters, or as a reduced fraction, 100 units per milliliter. Making note of all of these details, it's time to actually look at my problem. I'm going to put the details that I collected along the top of my page. First, I have the patient's weight of 143 pounds. I need to convert that to kilograms. Normally I'd round to tenths, but this one comes out to be a whole number. I know that I'm going to need to calculate an initial bolus and initial infusion, so I copy those two details from the heparin protocol. I'm going to need the meds, so I record the strength of the bolus medication and the strength of the IV medication. Remember, with the IV, you can use either strength, the one that's reduced or the one that has not been reduced. Now, for the initial bolus, the protocol tells me that I am to give the patient 60 units per kilogram. So I take the 60 units per kilogram and I multiply by the weight to cancel the label of kilograms. Using my calculator, I have 60 times 65 for a total of 3,900 units. This will be appropriate because it's below the maximum of 5,000. So I'll plan to give my patient 3,900 units. In the second part of the problem, I'm asked to calculate the initial bolus in milliliters. I'll take my answer from part A and convert it to milliliters. I'll use the bolus medication. I'm going to set up dimensional analysis, but you could use any of the methods. This is given as a one-time dose, which is why I put the desired amount over 1. In the vial, I have 5,000 units per 1 milliliter. My label of units cancels. I already have the 3,900 on my calculator. I'll divide this by 5,000. When I look at my answer, I normally would round it to the hundredths place because it's less than 1 milliliter. But in this case, I don't need to round at all. Part C asks me for the dose in units per hour for the initial infusion. I'm going back to the information that I copied from the cardiology protocol, and the initial infusion is to be 12 units per kilogram per hour. So I'll take that amount and I'll multiply it by the patient's weight of 65 kilograms. My calculator will help me with the math. 65 times 12 means that the patient should receive 780 units per hour. Again, I want to check and make sure that this is below the maximum, and it is, so we can continue with this amount. Part D asks me to change this to milliliters per hour. Going to milliliters per hour means that I can use any method. I'm going to set up dimensional analysis, but you can use your preferred method. I'll start with the information that I calculated in Part C. To do my calculations, I'll use the med that's in the IV bag. As we talked about before, you can use the full numbers or you can use the reduced fraction that expresses the concentration. My label of units cancels, which will give me an answer in milliliters per hour. From before, I have the number of units on the calculator, so I'll multiply by 250 and divide by 25,000. For milliliters per hour, I typically round to tenths. In this case, I do not need to round my answer. For Part E, I receive a PTT result of 34. In order to know what to do, I need to consult my protocol. On my protocol, I see that for 35 or less, which would include 34, I should repeat the initial bolus and increase the IV by 200 units per hour. In Part B, I calculated the initial bolus to be 0.78 milliliters. I'll administer that again. In Part C, I calculated that the patient should receive 780 units per hour. I'm to increase their heparin by 200 units per hour. Because these have the same label, these are the two numbers that I can add. The problem asks me for the new heparin dose in units per hour, so all I need to do is the addition. I don't even have to convert to milliliters. And so my new dose of heparin would be 980 units per hour. Once again, we've completed a heparin problem involving a protocol. There's been a ton of information, but each part of the problem is one simple step. In the last part, make sure that you're adding where you have like units. It would have been wrong to add the 200 to the 12 because the 12 is units per kilogram per hour. So by finding the part that has the matching label, we can then do the addition and complete the problem.